Hello everyone, in today's video we are going to learn how to find the particular integral. This is the continuation of the previous video based upon the topic linear differential equation with constant coefficients, where the general solution is equals to the sum of complementary function and particular integral. In the previous video we learned how to find the complementary function, that is yc, and in today's video we will learn how to find the particular integral, that is pi. Now see, we know that the general form of the linear equation of order n can be written in this form. Okay, now when we use capital D in place of small d by dx, means this derivative, then equation 1 means this reduces to this form. Now this can be written as, means this one can be represented by f of d into y is equals to f of x. Alright, now generally we can find the particular integral for non-homogeneous differential equations. Okay, so non-homogeneous means wherever this the RHS, that is f of x, is not equals to 0. So the particular integral is given by yp, which is equals to f of x by f of d. Okay, so now we know that capital D is equals to d by dx. Okay, that means wherever we will be taking wherever it is written like d of sine ax, it means that we will derive this, which is equals to a into cos ax. Fine, and 1 by d of f of x, it means that integration 1 by d means integration, so that is integration f of x dx. Now there are certain cases of finding particular integral, out of which case 1 is this one. When the equation is of this type, that is e to the power ax by f of d, then we will replace d by a. See, so let us see one example. So if we are asked to find the general solution of this equation, then its general solution is given by y is equals to yc plus yp, isn't it? We can find the complementary function easily, that is its auxiliary equation is y square minus 3m plus 2 is equals to 0. Now on solving this, we will get it as like this. Now on taking m common, this becomes m minus 2 minus 1 m minus 2, so we got m as 1 and 2. So therefore its complementary function is c1 ex plus c2 e to the power 2x. Okay, now let us find its yp, that is its particular integral. So its particular integral is equals to e to the power 3x by d square minus 3d plus 2. Okay, here while finding the complementary function, we will take this auxiliary equation or this equation equals to 0. Okay, because we can find the complementary function only for homogeneous equation, so we need to take it 0 while finding the complementary function. Okay, and now for finding the yp, here see, here a is how much, 3, so we will put 3 in place of d. So here this is 3 square minus 3 into 3 plus 2, so this is 3 square is 9 minus 3 into 3, 9 cancelled, which is equals to e to the power 3x by 2. Fine, now the general solution is equals to y equals to yc plus yp, isn't it? That is equals to c1 e to the power x plus c2 e to the power 2x plus this is e to the power 3x by 2. Okay, so this is the answer. Now let us see the second case. So the second case states that 1 by f of d square sine ax is equals to 1 by f of minus a square sine ax. This means that wherever in the equation of f of d there will be d square, then we will be replacing that d square by minus a square. Okay, for example, let us understand this with the help of an example. So here is a question that is find the particular integral of this equation. Then the particular integral yp is equals to cos 2x by d square plus 1. Okay, so now this is equals to cos 2x. Here a is how much? 2. So in place of d square we will be writing minus 2 square plus 1. Okay, which is equals to cos 2x by minus 4 plus 1, which is equals to minus of cos 2x by 3. Okay, so this is how we solve this type of questions. This formula is applicable for both sin x and cos x. Okay, and this is applicable only when this denominator is not equals to 0. When the denominator is equals to 0, that is when f of minus a square is equals to 0, then means the formula that will be applying is different. Okay, means this one won't be applicable in that case. Let us see next case, that is case 3. Case 3 is 1 by f of d of eax into vx, where vx is a function of x. Okay, then in that case it will be e to the power ax into 1 by f of d plus a, okay, into vx. So this formula is applicable when the denominator of case 1 is equals to 0. Okay, case 1 is also applicable where we used to replace d by a. So this is applicable only when the denominator is not equals to 0, but when the denominator is equals to 0, that time we will be using this formula. Okay, so let us see how to use this. So this formula can be used actually in this case and one more in this type of case where the function, that is the function of f of x, that is the RHS, is the product of a function of x and exponential function. Okay, that is e to the power ax. So let us see this example. Now here we have to find its particular integral. So yp is equals to e to the power 2x by d square minus 4d plus 4. So when we closely observe this, so this is the formula of d minus 2 whole square. Okay, so this is somewhat like this. Now when we will be using 2 in place of d, then we will get this as e to the power 2x by 2 minus 2 whole square. This is becoming 0, isn't it? So then this will become infinity. So that's why we will use this formula, that is e to the power 2x into 1 by d minus 2 whole square minus 2 and one more plus 2. Oh. This is e to the power 2x into 1 by d plus a. D plus a means here a is how much? 2. See, a is 2, so therefore d plus 2, and minus 2 is already there in the question, so 1 minus 2, then it's whole square, and here nothing is there means it's 1. Okay, so this plus 2 minus 2 cancels and this reduces to e to the power 2x into 1 by d square of 1. Okay, now this is equals to e to the power x, and 1 by d means integration, d square means 2 times integration. Okay, so first we will get it x, so one more time on integrating it one more time, that is this is also equals to 1 by d. Okay, so actually this is e to the power 2x 1 by d of x. Now this is equals to e to the power 2x into x square by 2. Alright, so this is the answer, this is the final particular integral of this question. Okay, and the second case when we will be using this formula is when the RHS of this equation is of this type. See, e to the power ax into vx, where vx is what? A function of x. So now here see, y is equals to yp, we are finding the particular integral, so that's why yp is equals to x into e to the power 2x by d square plus 1. Now this according to the formula, this will become e to the power 2x by, in place of d we will write d plus a, so here a is how much? 2, So this is d plus 2 whole square plus 1 into x. Okay, here vx is what? X. Now this is equals to e to the power 2x 1 by, when we will open this reduces to, or this becomes d square plus 4d plus 4 plus 1, that is 5 into x. Okay, now this is equals to e to the power 2x, and this is 1 by, when we take 5 common, this will become d, means 1 plus d square plus 4d by 5. We will write it in this form, that is 1 plus d term, okay, into x. Why? Because see, when we will take this above, means this becomes what? 1 plus d square plus 4d by 5 whole inverse into x, isn't it? So this is actually somewhat of this type, 1 plus x whole inverse, isn't it? And its binomial expansion is what? 1 minus x plus x square, again minus x cube plus x4, okay, of this type, and so on. So on expanding this, we will get it as 1 minus, here x is what? D square plus 4d by 5, so d square plus 4d by 5 plus d square plus 4d by 5 whole square, okay, and so on, whole into x. We won't go further because here it's only x, okay. And see, d means what? D by dx. So this means derivating x. When x is derivated twice, when it's derivated once, then we will get 1. Again, when we will derivate 1, then we will get 0. Okay, so the third derivative, fourth derivative won't exist. Fine. So this will exist only the first, this will exist only up to first derivative. When we will derivate it second time, it will become 0, okay, and so on. So from second derivative only it won't exist. So therefore we won't go further, or we will consider only up to this term. So this becomes e to the power 2x by 5, and this is 1 minus, when, okay fine, d square plus 4d by 5 whole into x. Okay, now this is equals to e to the power 2x by 5. We will take x inside, that is x minus, when this is derivated twice it will become 0, plus 4 into derivative of x, so that is 1, okay, 4 into derivative of x, that is 1 by 5. Fine. Okay, let me show this over here, that is d by dx of x is how much? 1. Again, d by dx of 1 is how much? 0, isn't it? So now this is equals to e to the power 2x by 5 whole into x minus 4 by 5. Okay, now this can be written as e to the power 2x by 5 into 5x minus 4 by 5. Okay, which is equals to e to the power 2x by 25 into 5x minus 4. Okay, so this is the final answer. Okay, so let us see the fourth case. The fourth case is when the denominator over here, that is f of minus a square, becomes 0, then 1 by d square plus a square of cos ax becomes x by 2a sin ax, and 1 by d square plus a square sin ax becomes minus of x by 2a cos ax. Okay, so let us see this with the help of an example. So here it is asked to find the particular integral of this. So now yp is equals to cos x by d square plus 1. So here a is how much? 1. So this is equals to x by 2, a is 1 into sin ax. A is again 1, so this is x. So this is x by 2 sin x. Okay, we can directly use this formula. Now let us see the fifth case, that is 1 by f of d of x vx, where vx is a function of x that can be sin x, cos x, anything. Okay, a function of x, which is equals to x by 1 by f of d. Now this is equals to x into 1 by f of d into v plus d by d means derivative of this into v. Okay, so now let me explain this in a better way through an example. So if here we are asked to find the particular integral of this, then its answer is yp is equals to x sin x, here sin x is vx, okay, by d square plus 4. Now this is equals to x into 1 by d square plus 4 into sin x plus d by d of d of 1 by d square plus 4 into v, that is sin x. Okay, see, now this is equals to x by x into 1 by, see here in place of d square we will be using minus 1 square because here a is 1. Okay, so this will be minus 1 square plus 4 into sin x plus, on derivating this is what, 1 by x, and derivative of 1 by x is how much, minus 1 by x square. So this is minus 1 by d square plus 4 whole square into derivative of this d square plus 4, that is 2d. Alright, into sin x. Alright, so this is equals to x by, this is 4 minus 1, that is 3 into sin x, and this is minus 2d by, here also in place of d square we will be using minus 1 square, so that is minus 1 square plus 4 whole square into sin x. Okay, so this is equals to x sin x by 3 minus 2d by 4 minus 1 3, so this is 3 square sin x. Okay, so this is equals to x sin x by 3 minus 2 by 9 d sin x means, so this is derivative of sin x, that is cos x. Okay, so this is the particular integral of this equation. Alright.